In this video, we are going to talk about Bernoulli differential equations. And it really follows that first order linear that we talked about before. So with a Bernoulli differential equation, we're going to have something that can be written in the form of y prime plus some function p of x times y is equal to another function q of x times y to some power. This is where this one is a little bit different because we've got this extra y attached to that right-hand side's function in terms of x. And with Bernoulli differential equations, all we do is we make a substitution. We're going to let u equal y to the 1 minus n, and then we're going to have a substitution that we could create for y and y prime. And then that's going to turn this into something that's going to be first order linear. So let's look at an example. Let's say we have y prime plus 9x to the 8th y is equal to x to the 8th y to the 7th. So this is an example of a Bernoulli differential equation. I cannot combine those y terms because the exponents are different. So we have no choice but to use this technique. So here's our technique. We're going to let u equal y to the 1 minus n. And n is going to be the exponent on this y. So that's going to be y to the 1 minus 7, which is y to the negative 6. So let's talk about what we have. We have u equals y to the negative 6. From this, we are going to figure out what y is going to be. So let's solve this for y. So if I solve this for y, I would take this thing to the negative 1/6 power. And that would give me a y is equal to u to the negative 1/6. So remember, when we do substitutions, we have to do substitutions for everything. We start with really what you're doing is creating kind of like a dummy variable to help us get from point A to point B. So we create that variable, and then from there, we need a substitution for y, because I got to plug in something here and here, but then I also need the derivative of y. And we can find that easily by taking the derivative here. Bring that exponent down, subtract 1 from the exponent, and we need to show we took that derivative with respect to x, so we're going to tack on that u prime. But everything really hinged on this guy. So I'm going to just kind of make notes of these. Let me box that in. So now we're going to do our substitution step. And substituting into this. So y prime is equal to negative 1 over 6, u to the negative 7 over 6 times u prime plus 9x to the 8th times y. And y is equal to u to the negative 1 over 6. And that's going to be equal to x to the 8th times y to the 7th. And our y was u to the negative 1 over 6. So we're going to clean this up. This is pretty messy. So remember, I said this is guaranteed to be first order linear. All we have to do is tweak it. Right now, to be first order linear, I've got to have a 1 in front of that u prime. So how can I do that? Well, we can do that by dividing everything by that coefficient, negative 1/6 u to the negative 7 over 6. What I do to one term, I have to do to all the terms. Remember, math is always fair. So when I take this and divide it by itself, I'm going to be left with u prime. And then now I've got to figure out what's happening here. So I have negative 9 divided by negative 1 over 6. And when I do keep, change, flip, I'm going to get a 54 there. And it's going to be a negative. 54. That should be a positive 9 divided by a negative 1/6. And then we need to simplify the exponents. Remember, when we're dividing and we have the same base, we subtract the exponents. So check out what's going to happen here. We're going to see some magic. We're going to end up with 6 over 6, which is 1. So this is going to give me a u to the first power, and that should always happen when we do the substitution with Bernoulli. And then here you can see how this term is going to cancel with that. So I have x to the 8th divided by negative 1/6. Keep change flip, and we have that. So this guy is first order linear. So we're going to go through our process, find that integrating factor. So we're going to have e to the integral of negative 54 dx. And that's going to be negative 54x. Oh, hold on 1 minute. I simplified this, but I forgot my x term. Don't forget your x term, guys. So that's x to the 8th u. Sorry about that. So when I divided this, 9 divided by negative 1/6 gives me a negative 54, and then I still have that x to the 8th there. And then those exponents reduce to a 1 on the u. So first order linear. So integrating factor. My p of x is negative 54x to the 8th. When I integrate that, I'm going to get negative 54x to the 9th over 9. And that's going to be a negative 6x to the 9. The next step, multiply through. Or multiplying through by that first order linear. So I have e to the negative 6x to the 9th u prime minus 54x to the 8th u times e to the negative 6x to the 9th. Negative 6x to the 8th times integrating factor e to the negative 6x to the 9th. And then we're going to do our rewrite. That left-hand side can be rewritten as the integrating factor times u. Right-hand side we can't really do anything with. Okay, this is where you should stop and check. Is this equivalent to this? First times derivative of the second plus second times the derivative of the first. And the derivative of e to the u is e to the u times the derivative of the exponent. So you can see how this is equivalent to that left-hand side there. And then we integrate. And I'm going to put my integral sign right here because I could factor that negative 6 out. So the left-hand side is just going to be e to the negative 6x to the 9th times u. This side, I got to think about a u substitution. So my u here would be negative 6x to the 9th du is the derivative of that, negative 54x to the 8th. So you can see how that x to the 8th is going to be absorbed inside of this du, but we are missing the negative 54. We can multiply it in as long as we compensate on the outside. So now we're going to have 1 over 9. And when I integrate e to the u, I'm going to get e to the u. And then we're always going to have that plus c on the end. And then let's solve for u. So I'm going to divide everything by this term. So when I do that, let me write this step out. See how it cancels here. So we're going to have u equals, it's going to cancel here, 1 over 9 plus c e. And I'm bringing this up, so that's going to change the sign on the exponent. So we have taken this Bernoulli equation, we've done a substitution, and now we have integrated using our technique for first order linear, and now we have this. We've got one more substitution that we've got to make. remember that in the beginning, we said u was equal to y to the negative 6. So that u is really y to the negative 6. So there's our final answer for this guy. So let's go through one more. We're going to let y prime plus 5 over xy equal xy squared. So again, this is a Bernoulli differential equation. We know it is because we've got this y squared attached to this function of x. So that's your key. So technique, let u equal y to the 1 minus n. N is the exponent on this y. So it's going to be y to the 1 minus 2, which is y to the negative 1. So this is going to help us form some substitutions. So u equals y to the negative 1. Now we need to solve this for y. To solve this for y, we could raise this to the negative 1 power. What I do to one side, I have to do to the other. So that's going to tell me that y to the negative 1 to the negative 1 is really y is equal to u to the negative 1. And then we can get a derivative of y. To take the derivative of y, I'm going to use that power rule, bring the exponent down, subtract 1 from the exponent, and then we got to show we took the derivative with respect to x. So here's our substitutions. I'm going to box those in. Your next step, substitute. Y prime is going to be negative 1 u to the negative 2 times u prime. Remember, that's a u prime. That is not a u to the first power. Plus 5 over x. Substitute in for y. Y is u to the negative 1. That equals x times y squared. Y is u to the negative 1. I'm going to clean it up. When you have a power to a power, you multiply those together. So to make this in proper form for first order linear, we're going to divide everything by that coefficient negative u to the negative 2. So that's going to give me a u prime here. I'm going to have a negative 5 over x. And then to reduce these, remember it's top exponent minus bottom exponent, and we're going to get a u there. And then we're going to have a negative equals negative x here. Those are going to cancel. So this guy is first order linear. So let's use our technique. Integrating factor. E to the integral of negative 5 over x dx. So that's going to be negative 5 ln, absolute value of x. And that's really ln of x to the negative 5. So we're moving that back as an exponent so we can use properties to reduce this. And we're going to get x to the negative 5. We're not going to worry with the absolute value. We want a solution to this. So we're going to multiply. So we're going to multiply through by that integrating factor. So our rewrite. This is integrating factor times u. And then I'm going to simplify these. If I have negative x times x to the negative 5, we need to combine those exponents. When I'm multiplying, I have the same base. I add the exponents together. So that right-hand side condenses to negative x to the negative 4. This is a good place to check to make sure that this is equivalent to this. So to do that, I would do first times derivative of the second. plus second times derivative of the first. So is this the same thing as this? Well, we can see the first piece is, and now we got to think about what this actually means. So here's what we have in here. And isn't that the same thing as bringing this guy up, or thinking about it as top exponent minus bottom exponent? -5 minus 1 would give me a -6 on that. And then it's multiplied by u. So you can see how it checks out. Once you rewrite, integrate both sides. We're integrating with respect to x. So that left-hand side is x to the -5u. I'm going to add 1 to the exponent, divide by the new exponent. So I'm going to clean this up. So this is x to the -5u equals x to the -3 over 3 plus c. And then I want to get u by itself. So I'm going to divide everything by this. So I'm going to think about writing this way. I'm dividing by a positive there. Sorry about that. So I'm going to get u by itself. We've got to simplify these exponents. So what I really have is x to the -3 over 3x to the -5. We subtract those exponents. We're going to have -3 minus -5, which is going to be an x squared. And then I'm just going to move that negative exponent back to the numerator. And then our last step, let's remember that in the beginning we said u was equal to y to the -1, right? Going all the way back up here. So we're going to make that substitution here. So y to the -1 equals x squared over 3 plus cx to the 5th. So there's our final answer.